Hello students, today we will begin with unit number 6, that is solution of linear simultaneous equation. So see here, we are going to consider a system of linear equation with n unknowns which are represented here. So this is my first linear equation, this is second linear equation, this is third linear equation, and this is my last linear equation. See here, we have taken here n unknowns. Therefore, we have taken here n number of equations. If we have considered here 3 unknowns, then we have to just consider only 3 equations. So see here, it will start from, first equation will start from a11 x1 plus a12 x2 plus a13 x3 plus a14 x4 up to the last term, that is a1n xn is equal to b1. So see here, in all these equations x1, x2, x3, x4, x5 up to xn, these are the variables. These are the variables whose value we have to find out. We have to find the value of these unknown variables, that is x1, x2, x3 up to the n terms. And these terms a11, a12, a13, a21, a22, a23, these are the coefficients of these particular variables in their respective equations. So see here, I have written up to third equation only, and I have directly written here the last equation because we cannot write the up to the n terms. So I have written just here the last equation in terms of n, that is an1 x1 plus an2 x2 plus an3 x3 and it will be continued to the last term, that is ann xn is equal to bn. See here, we have to, what we have to do, they will provide us this set of linear equation and we have to find the value of variables, that is x1, x2, x3 up to xn. Don't worry, they will not provide us up to the xn terms. Xn means they will maximum provide us up to the fourth terms only, means they will provide us a set of linear equations with 3 unknowns or 4 unknowns. So what we have to do, we have to find the value of these unknown variables, that is x1, x2, x3, x4 and up to xn here. So in order to understand this theory, we have taken here n terms. So there are various methods by which we can solve this linear simultaneous equation. So there are two major types of method to obtain the solution of linear simultaneous equation. Which are these two major types? First is the direct method and second is the iterative method. So what will happen in direct method? So direct methods, they will use elimination of the variables. Means they are going to use elimination of variable technique, in which they are going to eliminate one variable from each equation. So they will transform the system of equation to triangular form. So by using this technique, they will transform the system of equation to triangular form, that is in triangular matrix, either lower triangular matrix or upper triangular matrix. So these are the few important methods which will come under these direct methods, that are Gauss-Jordan elimination method, Gauss elimination method. These are the direct methods. So second methods are iterative methods. These methods are recursive methods and they use successive approximation. These methods are recursive method, means we have to repeat the same method again and again. Repetitive methods, we have to apply the same formula again and again, and they use successive approximation, means whatever the values we have found out in equation number 1, in iteration number 1, whatever the values we have found out in iteration number 1, that we have to use in iteration number 2 to find the solution. Similarly, whatever the values found out in iteration number 2, that can be used in iteration number 3. So this is successive approximation. Similarly, the iteration are repeated till the required accuracy is obtained. We have to repeat the number of iterations, we have to repeat the same formula again and again, unless and until we have reached the desired accuracy. So example of these iterative methods are Jacobi's iterative method and Gauss-Seidel iterative method. So these are the methods that we are going to study in the further lectures. So in next lecture we are going to see substitution method that will be required while solving this direct method. Till then, thank you.